I'm going to cover the entire section here, 10.4, the entire binomial probability section. And we'll kind of go through everything, and that way you'll have a chance to review it all. And we're going to start first, though, with the lesson objectives. And the goal of today's lesson is going to be, number one, and primarily it's going to be to learn and use this binomial probability formula. By learning this formula, it'll allow us to calculate things such as how many people we have to staff for a certain day, depending on the size of the company. They'll use this quite a bit. So let's open with this question first. It says a coin is weighted such that the probability of heads is 2/3. So it's a weighted coin. It's going to land on heads 2/3 of the time. What's the probability of getting exactly 2 heads in 5 tosses of the coin? If I flip the coins 5 different times, what's my probability that exactly 2 of those times it's going to land on heads? And so let's think here. We got 5 tosses. 2 of them are heads. So let's see, we got 2 heads. That means the other 3 have to be tails. And we need to think about the probability of getting a heads. The probability of heads normally is 1/2. However, right here with this one, it's a weighted coin. So the weighted coin is going to be 2/3. So the probability of heads is going to be 2/3, which will make the probability of tails be 1/3. Now, if we were to simplify this a little bit further, it looks like we have 2 2/3, and this is all multiplication. So 2/3 squared, and then we've got 1/3 cubed. Okay, but the only difference with this is not the only way that we can do this. We can have a heads, then a tails, then a heads, then 2 tails. If we do that, that's going to be 2/3, 1/3, 2/3, 1/3, 1/3, but it's still going to simplify the same thing here. But there's more than one avenue here, which will bring us to our probability, more than one combination we can use, which will bring us to our formula. Our binomial probability formula is right here. And this would be a good one to have written down in your notes that you can reference later. It says basically the combination here, number of combinations we can have, times PR times times Q to the R n minus R. So we're going to go through this and kind of go through each individual portion. Alright, P is the probability of success. Whatever our probability of success is, we want to list that as our P. Q is going to be the opposite, okay, so 1 minus the probability of success, which is essentially our probability of failure. N and R, we've used those before. N is the number of times we're going to do something, and R is the number of successful results that we'll have. Alright, so let's bring back in, and that sounds kind of confusing, but let's bring in our previous example. The coin is weighted so that the probability of heads is 2/3. Let's use this one for our probability formula. So we want to find out the probability of getting exactly 2 heads. Alright, well, the probability of getting exactly 2 heads on this particular coin is we take the combination, however many times we can get successes out of our total number of trials, multiply that by the number of successes, multiply that by the number of failures, all raised to different powers. So let's kind of go through them one by one. Alright, so we've got this combination here, but first let's worry about this P, probability of success. Well, if it's going to land on heads 2/3 of the time, and we want to see it get on heads exactly 2 times, the probability of success would be 2/3. This is our weighted coin, so here we have P, we're going to switch that to 2/3. And this is still going to be raised to the R, we'll deal with that in a moment. Now over here we have Q, this is our probability of failure. And basically we're going to go 1 minus 2/3. 1 minus 2/3 is going to be 1/3. Now we need to determine what our N and R values are. N would be the number of times, independent trials, number of times we're doing this. In this case we're flipping the coin 5 different times, so N value is going to be 5. There's our N of 5. Now we also have an N up here that we'll need to change to. There we go. Change it to 5. Now our R value is the number of times we're going to have success. And this one, the probability of getting 2 heads. So the number of successes we're looking for is 2. So we're going to change our R value to 2. And if we change it here, we're going to have to change it here and here as well. There we go. Now we're just going to type this one into our calculator. See what it gives us for an answer. Okay, let's bring in a calculator. We'll bring in the TI Inspire first. Let's get rid of that. Okay, this says 5 choose 2. So we'll type that into our TI Inspire. And to do that, we go N, C, R. That's our combinations. 5, 2. Alright, now 5 choose 2. 2/3 squared. Alright, so then we'll go over here and we'll go 2/3 squared. 2 divided by 3 squared. 2/3 squared, 1/3. 5 minus 2 is just 3. So 1/3 cubed, essentially. One-third cubed. And then just hit enter. This will give you your probability of getting that. We can do it this way. You can also do it if you wanted to. You could do it this way, where you actually write out each one of them and then do all your combinations this way. This will take a lot longer, but that is possible as well. This should be your answer on it. This is according to rounding to the nearest 6 decimals, so that's okay. So that will give us our answer there. Now let's bring in the TI-84 in case you want to use that one. TI-84 is going to be really similar. We're going to do 5 choose. Now our combinations are over here in probability. We click our math button first. After we click math button, then we go over here to probability. Option 3 is our combinations. So 5 choose 2, and yours may look a little bit different than this, but it'll work just the same. 5 choose 2, and then we're going to multiply that one by let's see, 2/3. 2/3 squared times, oops, there we go, 1/3 cubed. And we hit enter and we get our answer there too. You can type this whole thing out if you'd like to. It makes it a little bit longer, but not impossible to do. So now that we've at least tried one, I want you to try a similar one. I'm going to bring this one up. Why don't you go ahead and try this one. Push pause right now, and then after you've calculated it all, come back and make sure you do both of them. Check your answer here to make sure that you got the right answer here. And this one I had it set up both ways, either 10 choose 2 or a 10 choose 4. This way, both of these two are similar processes. This one's just a little bit easier to type into your calculator, I think. But anyway, the number of successes on this one are 2 because we're trying to roll 2. We're trying to roll 2 rolls of 6s. And so this one we got to figure out the probability of getting a 6. So if you think of a standard die, it has 6 sides. Probability of getting a 6 is 1/6. Okay, one of those sides is going to be the number that we want, and then the probability of failure would be 5/6. It'd be the opposite. Notice these two numbers here, this 2 and the 8, always have to add up to the total number value that we have. In this case, it's 10. Okay, and the 6 and 4 will add up to that as well. That's going to be a key component as well. All right, now I want you to try one. And this one's similar to the previous ones, only it's a little bit different. Okay, if your die is rolled 10 times, find the probability that at most one roll is a 5. So we're not asking find the probability that exactly one, but we're saying at most one. So we need to determine what we're talking about here. At most one roll is a 5. So at most, let's see, that can be one roll is a 5, that's fine. 2 rolls cannot, that doesn't work. So if we got one roll that's a 5, we can also roll it 10 different times and never get a 5. That would be 0 rolls of 5. So the probability that at most one roll is a 5 is equal to the probability that 0 rolls are a 5 or that one roll is a 5. Either one, okay? So if you can kind of calculate the probability of finding 0 rolls being a 5 or one roll being a 5 and then add those two together, that will answer our question of at most one roll is a 5. So I want you to go ahead and do that one now. Go ahead and push pause and come back to me after you've got your answer. Okay, you should have found out that your answer is 0.48452. And again, we found out the probability that 0 rolls end up being a 5 and that one roll ends up being a 5. And then we added those two together. And that would give us at most one roll, either 0 or 1. That would be the most. Alright, now let's go, let's try another one here. This one says at least 2 rolls are 5s. At least 2 rolls are 5s. Well, if we're doing at least 2 rolls or 5s, what's the opposite of at least 2? That would have to be less than 2, so either a 0 or a 1, and really that's what we just found. Let me pull that back up here. That's what we just found right here, was that a 0 and a 1 added together equal this. So if the question then is changed, so it says at least 2 rolls are 5s, then that's the same thing as saying 1 minus the probability that 0 or 1 roll is a 5. So 1 minus whatever our last answer was. In this case, it's 0.48452, which would give us our answer here. Because it's slightly different, at least 2 is the opposite of 0 rolls being a 5 and 1 roll being a 5 together. So we already figured out what our previous answer was. Now we're just adding on to that. And just made one extra step is really all it is. All right. Now I'd like you to try this one. And this one, come back to me whenever you're done with it, but this one is just a little bit different with our probability. Don't write it as a fraction. The probability of success, and you've got to determine what a success here is. The probability that 7 students will prefer vanilla. So our successes are going to be that they prefer vanilla. And the success rate, the probability of success is 45%. So now we're not going to use a fraction, we're going to use 45% as our p-value in this case. So go ahead and do that now, and then push pause. Alright, hopefully you got both of these answers. And this one was pretty straightforward. That exactly 7 students would say that they prefer vanilla. These two down here, or this whole problem, I should say, is a little bit more complicated because it says at least 2. So that would be the opposite. That'd be 0 prefer it and 1 prefer it, and then we subtract that from 1, which is what we just did here. Alright, now I'd like you to try these two. This one will be a little bit crazy. I'll give you a little hint on this one. The 100 should not belong anywhere in your formula at all. Remember, there are 3 being tested. We need to find the probability that the sandals are all defective. So you're going to have something there that will not involve 100 at all. It's just there to kind of throw you off. So go ahead and try that one. Push pause now. Check your answer on these. This one is a 3 choose 3 because there are 3 being tested, and we're finding the probability that all 3 are defective. So 3 choose 3, and then the probability that they're defective right here would be 0.005. This is not 0.5, this is 1/2 of 1%. So when you convert that one to a decimal, it would be 0.005. So double check that one here. That 1 or more is defective is that we take the probability that 0 are defective, and then we subtract that from 1. That would be get us our accurate answer here. Alright, let's try this one here. The probability an employee at Acme Food will call in sick on Tuesday is 0.05. The shipping department has 9 workers. Find the probability that 2 or more workers will call in sick on Tuesday. Okay, so 2 or more, we're going to think of 2 or more. Is there a different way that we can write that? Let's see, the opposite of 2 or more would be 0 or 1. So basically what we're trying to do here is the probability that 2 or more will call in sick is equal to the probability of 1 minus the probability that 0 will call in sick, and then subtract the probability that 1 will call in sick as well. So that's essentially what we're looking for right here. So that's my hint. Go ahead and push pause now, and then you can come back after you've done the problem. Okay, check your answer here. This one did not end up being too bad as long as you could calculate the probability that 0 was sick and that 1 was sick. And this, so the probability that 2 or more people will miss next Tuesday is very, very small. Okay, there's not a lot of, you're talking about 7% basically of the time you'll have at least 2 people miss. So it's very small. So they use this to help them calculate their staffing needs for any sort of company. So this will end this this particular lesson. You can continue on and watch the next lesson if you'd like, or you can rewatch this lesson if you need a little bit more assistance.